All right. Let's see if this works. Yeah, I did the right thing. Hi, everyone. Is everybody having fun? My name's Rory.
And I'm Jordi.
And we work at a company called Ecometrica that does greenhouse gas accounting. And we have a big Django application, very much, I guess, a monolith, if you look at it like that. And we recently wanted to add in a RESTful API to it to serve, first of all, clients outside of our company and clients, and also a front end written in Backbone, so in a more modern JavaScript framework. And we started using Django REST Framework to do our API, and we are really excited. And we wanted to share it with you guys. So first, I want to talk about what is REST. I think this is the third time this weekend that somebody has explained REST. So maybe you take it more as our take on what is REST.
I count 4.
You count 4? All right. Mine's going to be the best. So in a literal term, REST means representational state transfer, which begs the question, what the hell does that mean? And I think on a more intrinsic way, it's really hard to nail down, but you have to figure that your application is made up of objects or database records or things that your users use. Your API will show a representation of them, and it's not in the actions of your API, but it's more how you move that representation from one place to another, from different URL, from different locations or states that manages actions and events in your application. So notice I was very careful not to use the word HTTP in my definition. So not all RESTful interfaces automatically mean HTTP. But if you read all the documentation, the first paper to really explain REST, it works really, really well with HTTP. And also notice I didn't say JSON. So modern, like a lot of APIs nowadays use JSON because it's very handy, but it doesn't have to be. There's a lot in XML. I'm sure if you're a networking guy from the 1980s, you could use like the X509 standard and write your RESTful interface with that. But they're not binded to technology. And hopefully in 20 years when technology changes, we can still use these concepts with, I don't know, Lisp, S expressions, and pigeons and whatnot.
So in order to give you an idea of what we're going to do here, we're going to give you a very simple example. We're going to build, sort of, during this talk, a REST API for a very simple website called photoshare.com, which, as you can imagine, does very simple things like you can upload photos, you can view them, and you can share the photo with your friends, like very many photo sharing websites you may be familiar with.
So, like, if you were designing this in 2003, right, how would you do this in a sort of maybe RPC, maybe if you were using SOAP? How would you design your API such that either external clients or maybe clients internally to your company could use photoshare.com, right? Well, you'd very innocently, especially if you're using a Django or web framework, design a series of URLs a bit like that, right? Oh, you post to here, and you can add a photo, and you put the body of the photo in the files, and boom, I send it to the database. I post a delete photo to delete a photo because my web browser only does post and gets. And I get to list the photos and show photos. So right away you notice, first of all, there's verbs in all these URLs, which might be a bit weird. And they're not really, you can't do multiple things with different URLs. Like one URL does one thing. However, if you're thinking of how to program this in Django, well, right away, oh, list photos, I'm going to have a view called list photos that I'm going to directly link to that. And go figure, it's probably going to call a method on my model called list photos. So it's really easy to program, right? And we did this in 2003, not because we were horrible people, but because it's really easy and really simple to program.
But then, in 2000, Roy Thomas Fielding came up with his PhD thesis, in which he defined REST, essentially. Later on, you can look at our slides and click on this link if you want to actually read the thesis. But so basically, the thing with REST is, remember, it was a representation of your resource, which in this case happens to be photos. The representation we've chosen this time is JSON. In order to do things with these photos, instead of having a bunch of URLs with verbs in them, you have just the representation, you transfer its state by modifying that representation and putting it back. So all the actual actions, all the actual modifications done by the user by modifying the JSON and then putting it back. The first thing to notice here is that we have a photos URL, and that photos URL has no verbs anymore. The verb has been moved into the HTTP protocol. Here's a simple example here. You can just get the photos, and this gives you like a list of photos with their IDs, titles, URLs, and the file that it links to. Sorry. Now, using the same URL and just a different HTTP verb, it's the same resource, but you can also create a photo by posting to the same URL. And this is going to give you back a representation of the photo you just created. So you first post to create the photo, you post nothing, you get back the representation of the thing you just created, and then using that representation you can do further things to it, like change the name of the photo, or actually upload a photo, for example. Or you could, to get a particular photo, it's also encoded in your URL, and you just get at the ID of the particular resource that you want.
So, what does this have to do with Django? Burnt 10 minutes explaining REST and haven't talked about Python at all or Django. The thesis of our talk here is writing a good RESTful API is hard. You need to think about it. You need to make some effort into it. Writing them in Django makes it a bit easier because Django is a good web framework that makes a lot of things easier. But DRF makes writing a RESTful API really easy and really straightforward. Who here uses Django in anger, like quite often? Who here doesn't really like uses Django forms, but maybe not like them or is okay with them? All right, cool. So suppose you didn't know about the Django REST framework, but you wanted to create a REST API. And your first inclination might be to do just this, where you create a Django view that takes a request. And from the request, you load the data in JSON. And then using the data you just loaded, you get your resource, which in this case is a photo. Now, this looks attractive because it seems simple, but it has certain problems. For example, what if you didn't even get JSON? What if your user posted, I don't know, an email or whatever? Well, then this view is just going to error out with a 500, and your user is going to get a very uninformative error message. 500 server error, our devs are working on it. What if they posted valid JSON, but with invalid data? For example, here we're looking for a photo ID attribute in the JSON. What if they didn't post that? Again, they're going to get a 500 error without any information of what went wrong. What if they posted valid JSON, valid data, but then you still on your own end have to go and tie this to the model manually. Manually, we have to go and say, okay, this JSON has to be tied to this photo ID thing, which might not even exist. This would give us, again, well, I guess we could rewrite it so it gets 400. But the point is, you're going to have to be manually tying in your JSON to the model. And all these things, validation of the JSON, validation of the data within the JSON, with the fields within the JSON, and tying to the model, that's what the Django REST framework does for you. So if we take sort of like the archetype of the perfect, bog standard Django view, for some definition of standard and your views on Django, it can kind of resume itself to this, where you'll have your Django model, which does your database. On top of that, you will define a form, which will validate and save from the model data that you get from your users. On top of that, you'll write your view in Django, which articulates the form to save to the model. And beyond that, you finally have the template, which is actually your HTML you're showing to your user, right? So this is how you'd write the Django app circa 2010. If you look at the Django REST framework, it's very, very similar. So again, these layers, like the skin of an onion, where you still have your Django models. So you share your Django models with your base application and all the business logic contained therein. On top of that, you have a thing, instead of a form, they have a thing called a serializer, which is pretty much very close to a Django form where you define fields on it and validation rules and whatnot, and the Django REST framework will use that to show validation and to save and get data from your models. On top of that, you have views. So you have a very good series of generic views in the Django REST framework. And being a RESTful API and only having access to sort of 4 verbs, your generic views become a lot more simplified and powerful because all your business logic and all your complex stuff is pushed down to the model in the serializer. And on top of that, finally, they have a thing called a renderer, which is basically like a template. But usually, you're rendering the stuff pretty standard like XML or JSON, and you never actually modify that yourself. You just use the stock ones.
So just to get a bit more concrete, this is a rough example of what we're going to be doing. Actually, we actually have code for this if you want to download it later. It's a very simple photo model, has everything you expect, title, photo, and user. We have just a variety of fields here, char fields, a file field, and an integer field with the likes. Say you want to record how many times the photo was liked. And a couple of foreign relations keys as well, to viewers and users, very standard. Now this part is getting more interesting because this actually already is Django REST Framework code. The first is the serializer. Like we said earlier, this is very similar to a model. To a form, which ties it to a model. So now forms, the thing that we're comparing in here is to HTML forms. You know, like a form element in a page. The serializer is very similar, but instead of posting HTML, you're posting JSON or anything else you can serialize. It's very simple. All it needs is a single meta class. That's the bare minimum that indicates which model you're tying the serializer to. In this case, to our photo model. And then later on, the view is being derived from a Django REST Framework view that, as you can see, does retrieve, update, and destroy API view. So just with that, by deriving from that one view, you already get all the functionality of getting a photo, posting it to create a new one, and putting it to modify it. And again, the minimum you have to define for a Django REST Framework view is just a serializer, which we just defined above, and a query set that tells you which photos can be reached through this view.
All right. So if we look, sorry, passive aggressive. We took a look at those 7 lines of code, right? That's basically all the code that's coming into our that we use to feed this live demo. So right off the bat, we talked about this generic view that did the retrieve, update, and destroy. Well, Django REST Framework for you stock offers this sort of HTML view onto your API, which is very akin to sort of the Django admin, except it uses all your serializers and all your models, all your business logic you write in there. You can sort of articulate instead of fighting with curl and figuring out the right options in a shell, right? So this is what they call the API renderer, but you still have a JSON renderer. So if you use this with a web client, if you use this with a curl or a request or whatnot, this is what the JSON they'd actually see. And so you can inspect the JSON at every step for every GET request. Vice versa, in the HTML view, you have this raw data view which matches the media type you asked for. In this case, is JSON, right? And as we said, you have the get, boom. We have the delete, which actually activates the delete option because we requested a generic view that uses the retrieve, update, the destroy part. And we have a put, so we can change the form. If I look at the HTML form, presenting again, let me throw an exclamation mark, and it'll put, sorry, yeah, I remember this. So there's validation. So this is where the put form I gave into was given to my serializer. My serializer says, you didn't provide a photo. This is your error. I'm returning you a 400 bad request. So if I put photo and I put, it will update. There we go, 200, everything's okay. And this is the data it returned in a JSON form. Again, this HTML API is just there for you to debug and to see. But it is fully protected. You still need to authenticate using the full authentication system. And there's no powers that are given to this that are not beyond the scope of what your API provides. So if your view blocks certain things, it'll be the HTML API will do that. This is really handy for our front-end dev because we can just point him to this and say, this is what the API will do. And, and he can play around with it without having to like type stuff in jQuery or find the right plugin in Chrome to do it for him, basically. Finally, the last thing is this options key. So if I click on options, the Django REST Framework actually will return a JSON representation showing the definition of every field I specified in my serializer. So it'll say, oh, right, so this title has to be a string. Likes has to be an integer, right? It's required. Users, well, it's a choice type. You can feed that into a dropdown, and here are all the valid choices for this serializer right now. So my front-end developer calls in options, builds up his form dynamically, and returns it back to me. And if I add or remove a field, his front-end updates almost immediately. And I don't have to talk with him. He's a nice guy, but he can use the API is self-describing almost. If I go back again, there we go.
So the Django REST framework, sadly, is not all sunshine and rainbows. As we were using it, we came across some limitations of it. Mostly is about it's a framework, so it's meant to be used in a particular way, much like Django. And much like Django, if you try to stray from the path of what the designers intended to happen, if you want to replace a serializer or you want to do something weird with a form, then you end up fighting against the framework and you end up having to replace more and more parts of it. That was really, overall, the biggest problem with it. So, for example, fields. Remember that we said that a serializer, you can specify which fields you want to serialize for a particular model. Ordinarily, if you don't just... The example before was just with a class, with a meta class meta, and you specified the model you were serializing, that would serialize all the fields. But if for whatever reason you don't want to serialize all the fields, for example, for a user, you don't want to serialize their ID or anything, just their email and name, you can manually specify as members of your class, of your serializer class. Now this is defined when the model is loaded, when Django first loads, it's static. Those fields really cannot change. However, if you don't want this, you can do it dynamically. You can override the fields property of the serializer. And, in this case happens to be static again. But you can imagine you can do more complicated things here. One example is, suppose the user is allowed to define their own questionnaire, which is the example we had to deal with. They can define their own questionnaire, and the questionnaire they can define different kinds of questions, like drop-downs or free-form fields or numbers or whatever. So the user can define the fields. And then when that happens, then you have to keep overriding more and more functions, usually. Because usually the Django REST framework also requires to define get fields in addition to fields. Because they're all tied together in the way that the framework is designed. So you end up defining more and more, overriding more and more of the Django REST framework classes.
Another issue we've hit is the idea of a hierarchy of resources. So to use a bad analogy, let's say on our photo sharing app, we have a requirement for a feature of albums there, where you can put photos in albums, and some photos are part of a given album, some photos are not part of a given album, right? So ideally in a REST framework, you'll use the 404 not found to tell your user, okay, this resource as you described it, as you request, does not exist. So if a user requested, try this URL and give the ID of an album that does not exist at all, or that he does not have access to, it'll give him a 404. So if that ID 42 is incorrect, it should give him a 404. And in addition, if he specifies the ID of a photo in that album, that the photo might exist, but it's not part of that album number 42, it should again give him a 404 to tell him the resource, as you described it in this URL, does not exist at all. To do this properly in the Django REST framework, it gets very complicated because there's no concept of sort of context, or this view is a sub-resource of this view. And such, you're at repeatedly, especially if you have like an arborescence of multiple end views that work off one top-level album or object or resource, you wind up doing this repeatedly, or trying to find how to structure your classes such that you can get the base resource, get the proper error messages that are consistent, and yet in the sub-resources do extra things to fetch things. However, just as an aside, this is the stock Django get object or 404. So the exception it returns, the Django REST framework gobbles it up, throws up a 404 page to your user, and runs with it. And even with the HTML view works perfectly.
So remember that back a little while ago we showed you that there's like an options HTTP verb that will give you what your resource can accept. What are the valid fields for this resource? Now, one of the problems is, remember also that the Django REST framework is layered, like Django itself. There's a model, there's a serializer, there's a view, and they're very walled off from each other. By default, the serializer does not know very much about the model other than the fields it has, and it does not know much about the view. So for example, one thing a serializer could want to know is the request. But the request, like that is the HTTP request, you know, the user, the actual HTTP headers and everything. Yeah. Those are known by the view. So in order to get this extra context that serializer might want, and here's the reason why you might want it. For example, say you want to know which users are allowed to share this photo. Now, by default, unless you do more twiddling around with the Django REST framework, it's going to show you all the users because the serializer has no context to work with. It just shows you all of them. It knows nothing about the model, so it has no context with it. The model itself usually knows which users are associated to it, but not the serializer. So you have to keep breaking through the barriers of this onion, which again results in overriding more and more of the functions of your superclasses. And the Django REST framework documentation at some point actually says, just read our source code to know what to do. So the problem here, for example, is, I mean, we have Jordi and Rory here who can look at this photo, which is fine. But by default, it's also going to show, you know, Alice and Bob. And I mean,
they're nice people. Maybe they could be our friends. Maybe they don't want to see our photos. But
yeah, I mean, so they shouldn't be there. So, like I said, you can work through it, but you end up sort of realizing that, well, the Django REST framework is sort of, you're working against it a little in order to get some of these things accomplished.
Just one final comment. You might have heard us say we read and read a lot of Django REST framework code in the framework, but it's really well written. I had to debug something in Ansible on Friday, and I can't wait to get back to Django REST framework because it's very clear, and obviously they've hit the same sort of problems and open it up to overriding methods, overriding properties, overriding what you need to get into the right place. All right.
Well, thank you. That's all.
All right. Thank you both for the talk. Now we have a couple of minutes now for questions. So if you have any short questions that you want to direct to the speaker, let us know.
Just go ahead.
Yeah, use the mic so they can record.
Oh, yeah.
Thanks for the talk. You talked about the problem with hierarchical resource URLs. Is that a requirement that the Django REST framework puts on you that you structure your URL that way, or is that a decision that you made in your app?
So it seems like a very natural thing to say, well, photos go in albums. It's not a requirement of the Django REST framework, I suppose. I mean, you can map any URL to any view, and you could conceivably do a different view, but like this whole idea of a resource depends on a different resource. I mean, the Django REST framework is built very much on resources. This whole idea that there's a sub-resource apparently seems to be popular enough that I actually found a Django app for the Django REST framework called Django REST Framework Nested something or other. So it looks like it's not a problem that only we had. It looks like it's a problem general enough for people to have this, to have the urge to create an app for it. So, I mean, it's not exactly a requirement of Django REST framework, but it seems like a very natural thing you want to do that other people have done it as well.
To add to that, we use the stock Django URL mapping with regexes, so you can structure it any way you want. We just do it because it's conceptually, well, like for security-wise, you can compartmentalize our users' data into what is interested for them in this situation, this context. Thanks.
Any other questions? Okay, well, thank you again for the presentation.